Hello guys, this is Prime Concepts. I'm here now to analyze the final concept on location of image on a concave mirror. Number 6 is the final one we have, right? So I believe these things are not much for you to really know. If you have been following this video in sequence, you would understand this without cramming it. I will do a video using a scale diagram to do one of these so that you can see how exact it can be when you use your scale diagram. Now we'll be looking at when the object is placed between our focal point and the pole of our mirror, where would the image be formed and what will be the properties of this image that is formed. Now let's quickly look at this. So this is my concave mirror. So this is what I have, and then this is my pole. This is F, this is C. Now when our object is placed between F and P, which is somewhere around here, so I'm going to indicate my object like this. Now, I'm using one of the rules which says you have parallel line. So when you have a parallel line, when it hits your mirror, where will it reflect through? You are very correct. So it will reflect through the focal point in this way, right? Yes. Now, I'm going to use a second rule, but let me make this line better. Now, I'm going to use another rule, which when your ray hits your pole, it will obey the law of reflection. So I have this. When it hits, it will come out this way. So it will come out this way so that the law of reflection is obeyed. Now, if you watch this, remember, our image is formed where our reflected rays intersect. Now, if you watch these lines, you'll notice that it's spreading away. It's diverging, right? It's spreading away. So it means that if I keep drawing this, there will be no point where these two lines will meet here because it will keep diverging away from it, right? But if you watch carefully, you'll notice that since it is diverging or is spreading away at this point, it means if I go backward, it will eventually meet somewhere at the back. So let's check so that we can see. So this is the ray. So if I take it backwards, I would have something like this. If I take this other one backwards, I would have something like this. So can you see this? Can you see their points of intersection? So it means that these two lines would intersect somewhere at the back of our mirror. Now, since the point of intersection is above, it means that my line would go facing up, no longer facing down. So I would have it like this, upwards like this, right? Now, you can clearly see that your image is pointing up, right? So with this, we can bring out the properties of this image from, and this is really a very special case, right? We've mentioned that special case to us. So let's list the properties of this image formed. Now, number one property is that the image is formed behind the mirror. I hope you know this is the back of our mirror. So this is the back of our mirror. This part is the front of our mirror. So, and the image is there. So it means that image is formed behind the mirror. So that is one property, too important for us to know. Now, if you check position 1, we considered 2, 3, 4, 5. The first 5 positions we considered, the images were always formed in front of the mirror, which made them to be what? Real images. So this is the only position for a concave mirror where the image is formed behind the mirror. Every other condition, the images are formed where? In front of the mirror. So take note of this very important point, right? Now, any image that is formed behind the mirror, what do you say about that image? You are very correct. The image is what? Virtual. The image is virtual. So when you say virtual, it simply means that the image cannot be seen or caught on the screen. So it's a virtual image. It's formed behind the mirror. Now, what can you also observe from this? Number 3, The image is standing very tall and erect. So we can say that the image is what now? Erect. Or we can say the image is upright. Now, this is my object. Can you see the size of this object? Can you compare it to the size of this image? So it is very clear that in this case, our image is highly magnified. It is not just magnified, it is what? Highly magnified. So number 4, image is highly magnified. Our image is what? Highly magnified. So you can see the image is much bigger than the object. Now, I want to mention a very important thing for you to note. Now, we have our concave mirror, we have our convex mirror. These two mirrors have very important applications. I'll be mentioning the application for a concave mirror. Then when we do convex, I'll mention the application. Now, what is the application? One of the major applications of your concave mirror. The concave mirror is a mirror that is usually used as a shaving mirror. So we use the concave mirror for shaving. We don't usually prefer to use the convex mirror for shaving. When we get to convex, you know why we don't like the convex as a shaving mirror. But how do you remember that the concave mirror is used as a shaving mirror? Our concave, so this cave and shave. So when you hear the word cave, you should know it's associated with what? Shave. So our concave mirror is simply used as a shaving mirror. And why do we use it as a shaving mirror and not the convex mirror? It is simply because the concave mirror is capable of producing a high level of magnification, and it produces an erect image. So you want to shave, you want a mirror that when you're viewing yourself, you would see those hairs very magnified so that you can know which of them you still need to remove. So that is why we use our concave mirror as a shaving mirror. And of course, it is not at all object positions that the concave mirror that can serve as a shaving mirror. So the condition for which a concave mirror can be used as a shaving mirror is this condition, which is number 6 condition, when the object is between F and P. So they can ask you in your exams, if you're writing your SAT exam, your NEET exam, your G exam, you're doing AP physics, you would see some of these kind of questions. They will ask you, at what point in front of a mirror will an object be positioned so that the concave mirror can be used as a shaving mirror? Very simple. The object should be placed between F and what? P, so that that mirror at that point can serve as what? A shaving mirror. So I believe this concept is very clear. Now, and you should also note that it is only this condition where the concave mirror will give us a virtual image. So if you have watched my video up till this point, please do well to hit the subscribe button, like my video, comment and share with your friends. If you have been watching me and following me consistently from Nigeria, I really appreciate you. You've been following from India, I appreciate you. From Canada, from the US, from UK, I really appreciate you. Please do well to keep watching my videos and share with your friends so that they can also benefit. Remember, this is Prime Concept. Thank you.